Okay, so given the 5 things that are needed for oils and natural gas recovery, sometimes one or two of those parameters are not met, and the precious fluids cannot be recovered. This happens sometimes when there is a potential for all but the migration to occur. So the migration again is from the source rock to the reservoir rock. And this happens due to the impermeable nature of the source rock itself. Here is when hydraulic fracturing or fracking is useful. Hydraulic fracturing or fracking is a process through which fractures are made in the source rock, which opens up pathways for the fluids that are there to flow through and into the reservoir rock. So this is outlined in figure 7.33 of your book, by the way, if you want to look at it with more detail. But fracking is very useful again for oil and gas recovery, but in many areas it's a concern environmentally. But it's still under research whether or not we should be as concerned as some people put it. The fluids used in the fracturing process are mostly water, but some of the chemicals involved are actually toxic. So there is concern that these chemicals involved may flow into areas of groundwater residence that is nearby, for example. There's also a small concern for the increased seismicity in areas where fracking is done, but there is very conflicting research regarding the second point, as some people argue that smaller earthquakes may actually be good to prevent larger ones to occur, for example, and we'll cover this in chapter 9 a little more. So overall, fracking is not as common, but after having done an internship with one of the biggest oil companies this last spring, I can tell you that that is where the oil and gas recovery techniques are heading. It is very useful to, for getting those precious fluids, but it's still not as common due to the concern that it has towards damaging our environment. All right, so lastly, for this chapter, let's take a look at the carbon cycle. Most carbon is bonded chemically to other elements to form compounds such as carbon dioxide, calcite, and other hydrocarbons found in coal and petroleum, for example. Carbon is also the basic building block of life, as you probably know. So one of the most active parts of the carbon cycle is the movement of carbon dioxide from atmosphere to biosphere and back from the biosphere to the atmosphere. So CO2, or carbon dioxide, is very significant because it is a greenhouse gas, meaning it's good at absorbing energy that is emitted by the Earth back into space. So, because it's good at absorbing that energy that is re-radiated back into space, it kind of keeps it enclosed, and so it overall contributes to the overall heating. And we'll look at this process in further detail in chapter 20. Through photosynthesis, plants will absorb the CO2 from the atmosphere to produce the essential organic compounds that are needed for their growth. Later on, the animals that in some way or another consume these plants will use these organic compounds that the plants produced as sources of energy. And through this process of respiration, CO2 is returned to the atmosphere. So respiration from those animals is what causes the CO2 to be returned to the atmosphere in the biosphere-atmosphere relationship. The same process happens in the sea, where photosynthetic plankton plays the part of plants on land. The plankton does not always get consumed, though. Sometimes it gets buried by sediment after it perishes. So some of the carbon remains are captured in the sediment itself, which is what we discussed in the last slide of how these sediments contain the carbon remains that turn eventually into oil and gas. So over long spans of times, a lot of the biomass that does get buried within that sediment, and if under the right conditions, will become deposits of fossil fuels, right? Like we just discussed. Some of these get recovered and used to generate energy, as we saw, which means that they are a huge release of CO2 back into the atmosphere. And the problem with fossil fuels being burned is not the cycle itself, but rather the rate at which these massive amounts of buried biomass are being exhumed into the atmosphere. Some of the carbon itself moves from the geosphere and hydrosphere into the atmosphere as well. For example, in volcanic activity, there are great amounts of CO2 that are released into the atmosphere. One way in which CO2 gets back into the hydrosphere and geosphere is by the combination of CO2 with water and then precipitating as acid rain, and later that bicarbonate ion that remains from the chemical weathering process, all of that we covered in chapter 6, that will be carried to the oceans where the microscopic organisms use it again for the usage to make their exoskeletons and making their calcium carbonate. So these organisms die, get buried, and the cycle begins all again. In fact, most of the carbon remains in the crust and the atmosphere layer of our planet. So most of it is near the surface of our planet. There's a few exceptions. One of them is the carbon that gets buried deep enough and is perhaps involved at subduction zones. So when a plate that contains those carbon-filled sediments gets buried deep enough, the slab of rock, the slab of the plate, the leading part of the plate, is buried, and at some point partial melting will start, as we saw in chapter 2 and 4. When this partial melting starts to occur, the carbon dioxide is later released as volatiles in the volcanic eruptions that are subsequent to that. And as we saw in chapter 5, the type of eruptions that happen in these scenarios are explosive volcanic eruptions, meaning there's a lot of gas within them and it flows up into the atmosphere, sometimes very high. So, in summary, as you just saw, carbon moves in all of the Earth's four spheres, and it's everywhere. It's in all the things that occur. So the Earth's four spheres try to achieve a balance of carbon, but in order for there to be one, we need to contribute the most for this process. And by the burning of the fossil fuels, we are incrementing the amount of CO2 in the atmosphere where it still should reside in the geosphere, for example. So we are changing that balance of the Earth in terms of the carbon amount. Okay, so I know that was a little bit too much for the carbon cycle. I don't think I quiz you too hard on it, but I might ask one or two things about where the carbon dioxide resides or how it moves from atmosphere to biosphere or from atmosphere to hydrosphere. Okay, so with that, we finished chapter 7. I hope the lecture was clear and useful, and as always, please let me know if you have any doubts that I can clarify.